All right, pre-calculus. Today we're going to do 11.1b, which is still talking about limits. This whole chapter is going to be talking about limits pretty much. So let's talk about some basic limits. Some basic limits. Let b and c be real numbers and n be a positive integer. So some limits that you'll see is limit of some number as x approaches c is just going to be that number. Limit of some value as x approaches c is just going to be that c value. Okay, so limit of x. Okay, so limit of x to some exponent as x approaches c is just going to be c to that exponent. Okay, and don't worry, we're going to go through these. Okay, I promise these will make more sense. And the limit, so these are rules, limit of a root, nth root of x as x approaches c is just the nth root of c. Okay, so these are really just the same thing as they are. Okay, but here the x is changed to c's because we want to know what happens as x approaches c. This one right here, if it's just some number, then that number is never going to change. Okay, so that's a constant. All right, so sometimes we can actually evaluate limits by direct substitution in well-behaved. Okay, so polynomials and rationals with non-zero denominators, functions such as the basic limits to the left. And actually, so these are the basic limits that we were looking at. So in the last section, we were actually looking at tables. In this one, we're going to use direct substitution. So what that means is here, I have the limit as x approaches -4. Okay, of this function 2x minus 3. So for direct substitution, I'm just going to take and I'm going to plug -4 in. So 2 times -4 is -8, minus 3 is -11. So my limit then is -11. Okay, let's take a look at the next one. So sine of x. So as sine approaches, or x approaches pi. So I'm going to find sine of pi. And if you think about your unit circle here, sine of pi, so my unit circle, pi is over here. So that value is -1, 0, and my sine is my y value, so that's just 0. Okay, so direct substitution, I just plug her right on in. Okay. Well, limits also have some other properties, and let's see if I can get a little bit closer to this so you guys can see it. Okay, I know it's not going to be the best. Let's see if I can maybe clear that up a little bit. All right, so you guys should have this on your paper too, so you might need to follow along on that one a little bit better. Properties of limits. So let b and c be real numbers, let n be a positive integer, and let f and c be functions with the following limits. Okay, so here, let's see if I can actually find a better picture. Hold on just a second. Okay, I'm going to share my screen with you guys. I'm going to show you guys this picture right here. Okay, so this picture right here does a good job of showing this. So it says the properties of limits. So given the limit of f of x equals L, so some function, okay, as x approaches c, your answer is just L, or the limit of some function as x approaches c is just k. So scalar multiplication, what this says is if we multiply the function times some number b, then our limit is just multiplied by that number b. If we add or subtract these two functions, then our limit is just adding or subtracting those two limits. Product, if we multiply two functions, then we just multiply those two limits. Quotient, if we divide those two functions and we're looking for a limit, then we just divide those two limits. And the same thing for a power. So if we raise some function to a power, then we just raise that limit to a power. Okay, so these are all things that you guys are familiar with. We're just making it look a little bit different now. Okay, so let me stop sharing my screen here and let's actually go through and evaluate some of these limits. Okay, so this one says, let's see, let me adjust my adjust my stuff again. Okay, so this one says evaluate each of the following limits. Oh, I forgot an E on there. So it says limit as x approaches 4 of x squared. So we're going to do just that. So we're going to plug this in. So that's going to be 4 squared, which is 16. Okay, so the limit, okay, we'll do direct substitution here and call her good. Okay, so the limit as x approaches 4 of 5, well, that's going to be just 5, right? So because this doesn't change, if we plug 4 in, it doesn't matter. Okay, so the limit as x approaches 4 for x squared plus 2x minus 5, so that's going to be 4 squared plus 2 times 4 minus 5, okay, and that's going to give us 19. And then our last one here, the limit as x approaches 4 of x squared plus 2x minus 5, which we just found out in the last one is 19, over x minus 1 over 3 is 19 over 3. Okay, so going ahead and do your assignment for this, not too bad, direct substitution, and then we'll go on to 11.2a. Have a great day.